Hello students, welcome to the class of Digital Signal Processing. This is your fourth class and we have already discussed the introduction, the mathematical representation, and also we have done several numerical questions like 5 to 8 numerical questions we have done. And also we discussed the ROC of the Z transform for all those questions. Now, whenever you take out the Z transform, whenever a discrete time signal is given to you and you have to find out the Z transform, it is mandatory that you take out the ROC. Without the ROC in the answer, you are not giving the complete answer. So keep in mind that you have to always give the ROC of any kind of discrete time signal on which you are performing the Z transform. Okay, for today's class, let's get started with the properties of Z transform. So in this list, the first thing that comes in is the linearity property. So the linearity property, what does it mean? Is if you are having two signals, say x1, n, this is a two discrete time signal, and this is x2, n. If the z transform of x1, n is x1, z, and if the z transform of x2, n is x2, z, then if you combine these two signals, x1n plus x2n, the Z transform of this will be the combination of x1z plus x2z. Okay, so this is your first property, which can also be written as weighted sum of two signals, weighted sum of two signals is equal to the weighted sum of the individual Z transform. Weighted sum of two signals equals the weighted sum of individual Z transform. And we have also seen this in the questions that we did. Right, because see, we had this question, the first question only, u of n and u of n minus 3. See, this question, which you had on the previous day, u of n minus u of n minus 3. So u of n was one signal, you can take it x1n, and u of n minus 3 is the other signal, or you can even take it minus of un minus 3. That is the second signal. So the Z transform of un and the Z transform of minus u of n minus 3 will together become the Z transform of this whole thing. That is what is meant by saying the linearity property. Now this word over here, this weighted word, this simply means that you have a constant multiplied over here. In this case, what is the Z transform? Here it will be, and this is getting added over here. That's it. Okay. And what will be the ROC of such kind of signals? When you are adding the Z transform of two signals, means when you are taking the Z transform of two signals, then the ROC is going to be the intersection of the individual Z transform. You have seen it previously also. ROC is the intersection of the ROC for x1z and ROC of x2z. Okay, so we can do a question on this. We'll do it later because already we have done one or two questions. Let's go with the other. Okay, let us do one question so that it becomes clear. Okay, 1 minute. Let me find a question. Okay, so suppose we have this question, delta of n minus 1. If I am giving you a question over here, let's do a problem here itself so that we'll get the understanding completely. So the question is, you have to find the Z transform of this signal, delta n minus un, or we'll just take it. Okay, delta n minus un. You have to find the Z transform of this signal. So what can we do is, we can think of this xn as made up of x1n plus x2n. Now here your x1n is delta n and x2n is minus un. So basically, you are adding delta n plus minus of un. Fine. Now we have learned how to take out the Z transform of this. Let us see. So it will become delta n, z to the power minus n is equals to minus infinity to infinity, plus n is equals to minus infinity to infinity. And this minus will be simply replaced here. And the inside will be u of n, z minus n. Now see, this is an impulse signal. It is present only at n is equals to 0, and at all other places the value is 0. Means at 0 the value is 1, and all other places it is 0. So this signal will be present only at n equals to 0, and that value is going to be 1. If you put n is equal to 0 over here, then this whole thing is going to become 1, and this signal is already 1. Delta n at 0, delta 0 is 1. The value of this, the Z transform of delta n, or the Z transform of an impulse signal placed at n equals to 0 will be 1. Simply 1. For this case, you know, un is starting from n equals to 0. So you are going to change the limit from n equals to 0 to infinity. Right? 1 is the value for un, z to the power minus n. Now again, this is a geometric series with the first term. Here in short, I am writing first term is 1. What is the second term? Z to the power minus 1, z to the power minus 2. This way it goes on. You know, the sum is a by 1 minus r. First term by 1 minus common ratio. First term is going to be 1 by 1 minus z inverse. Now, the ROC for this, that is the delta n, the whole entire z plane is the ROC for the first one. But the ROC for this one, that is z inverse, is z inverse lesser than 1. For this side, it is entire z plane. Entire z plane. And for this one, it is z inverse lesser than 1. So, if you take the intersection, only this is going to come. It means that if I take the whole z plane, and the second thing is, if you simplify this portion, what will you get? If you simplify this, it is going to be 1 by mod z lesser than 1. Mod z is greater than 1. So this is going to be a unit circle. And then outside of this, right? Mod z greater than 1. So finally, what is the answer? The intersection. So in intersection, only the outside portion will come. So the final ROC is the intersection of the ROC for Z1 intersection ROC of Z2. That will give you the final ROC. So the ROC is mod Z greater than 1. Fine. And here you saw the final answer for x of z is the x1z plus x2z. You can simplify it and write it 1 minus z inverse minus 1 by 1 minus z inverse. So this 1 and minus 1 will get cancelled. And in the answer, you're going to get minus z inverse by 1 minus z inverse. This is the Z transform, and the ROC for this delta n was entire Z plane, and for this one was mod of Z inverse lesser than 1. If you take the ROC of together, then it is the intersection. That's why it's going to be mod Z greater than 1. Got it? Okay, now one thing more which they sometimes ask is how to prove this linearity property. So it won't be asked in competitive exams, but in your university exams, it can be asked. So let's do the proving part also. So say Our signal is, okay, I hope this example is clear. I'll just remove this. Okay. Now if say, if x1z if x1z is the Z transform of x1n and x2z is the Z transform of x2n, right? This is the Z transform of x2n. Then Z transform of A into x1n plus B into x2n is going to be A into x1z plus B into x2z. So this part, the part in the if side is given to you. This is given. And this is the part that you need to prove. Okay. So let's go ahead. Now see this part, the full thing from here. We will start from the left-hand side. The left-hand side is given to us Z transform of A x1n plus B x2n. So what can we write this? By the formula for the Z transform, we can write it n is equals to minus infinity to infinity A x1n plus B x2n. Inside a bracket, you can put it B x2n and Z to the power minus n. Now just multiply this Z to the power minus n to both these terms. Ax1n Z to the power minus n plus Bx2n Z to the power minus n. This summation can be separated into both the terms. N is equals to minus infinity to infinity. Ax1n, as both of them are having this variable n, you can separate this summation. N equals to minus infinity to infinity. Bx2n Z to the power minus n. Now, if you take this A and B outside of this summation, take this A outside, it is n is equals to minus infinity to infinity x1n Z to the power minus n. Plus this side, it is B, n is equals to minus infinity to infinity x2n Z to the power minus n. Now, this full thing is what? x1z, A is there, and this full thing is what? x2z. So finally, you have proved it. Nothing very tough over here. Just write a formula for the Z transform and divide on, write a formula for the Z transform and separate the summation for the two terms. That's it. After that, take the constant out of it. Fine. Let's go on to the second property, which is called the time shifting property. Now, what is meant by time shifting actually is that if you shift the original signal by some duration of time, how is the Z transform of the signal going to change? So suppose I have the Z transform of Xn as X of Z. I am shifting this signal by say m units. Then what will be its Z transform? The time shifting property says that its Z transform will be Z to the power minus m X of Z. So if X of n is X of Z, then X of n minus 1, the Z transform of this one is going to be z to the power minus 1 x of z. If the z transform of x of n is x of z, then the z transform of x of n minus 1 is z to the power minus m x of z. Now there is a condition over here. There is a condition that initial conditions should be 0. Now what is the meaning of this? That there should be no value of the signal before 0. Means not before 0. The meaning is that at the initial time, whenever the signal you have started to take, there is nothing before the time you have started to acquire the signal. So initial conditions are 0. Now, first of all, let us understand what is the meaning of this time shifting property. So see, this is the signal. This is starting. Let us take this unit step sequence itself. It is starting from 0, 1, 2, 3. So this I am naming as un. Now, if I write it u of n minus 2, this signal is going to shift to 0.2. This means the signal at 0 will shift to 0.2. So it is going to be a right shift. Right? So 2, 3, 4, and 5. There were 4 things here. So the 0 will go to 2, 1 will go to 3, 2 will go to 4, and 3 will go to 5. So now this signal is u of n minus 2. Now, if you do the left shifting of the signal, u of n plus 2, in that case, what is going to happen? The signal is going to shift towards the left. So now it's going to start from minus 2, minus 3, minus 4, and minus 5. Okay. So, how we are getting the property, how we are going to get the z to the power minus m x to the power z, that we will show you. Just see over here. Have you understood this portion? I hope you have understood. U of n minus 2, you have shifted it towards the right. You have shifted this one towards the left. One thing, see over here one thing, that when you are shifting to the right or to the positive side, here you are having minus 2. And when you are shifting it towards the negative side or to the left side, that time you are having plus 2. So it's the different thing. Just for, in order for you to remember, I just emphasize this point. The basic thing is that it is u of n plus of minus of plus 2. Okay, and here it is u of n minus of minus 2. You can take this one as this way, minus plus 2. And this one as n minus minus 2. So basically, there has to be a minus over here, whether it is shifting right or left. And after that, the actual shift, it is plus. So minus into plus is becoming minus here. And here minus into minus is getting plus. So these things are just to remember. Okay, after practicing, these will come automatically to you. Now let's go to the proving part. So for the proving, what we have to do is, we have to prove that Z transform of x of n minus m is equal to z to the power minus m x of z. When will this happen? If a condition is already given that x of n, the Z transform for x of n is x of z. Okay, you have to prove this part. So again, we are going to do the same thing. This is the signal for us. Write the Z transform for this signal, n equals to minus infinity to infinity, x of n minus m, z to the power minus n, right? From here you are going. After that, see what we are going to do over here is that we will take, let n minus m is equal to p. So n will be equal to what? M plus p. Now, if you write the first equation, then this n is written in terms of m plus p. So first let us write the inner portion so that after that you will be able to understand what to write in the which variable is changing. So x m plus p into z to the power what? Give me a second, small mistake here. This is already n minus m, right? So what it will be here, n minus m is p. So x of p, z to the power minus of m plus p. So the variable that is changing now is p, minus infinity to infinity. Now, you can write this, p is equals to minus infinity to infinity, x of p, z to the power minus m into z to the power minus p. If I take this z to the power minus m outside, because p is the variable over here, so I take z to the power minus m outside. It is becoming p is equals to minus infinity to infinity, x of p, z to the power minus p. This is again a Z transform. You can replace this variable p by n, the original one. So basically it is the x of z. And this is Z transform of minus n. Sorry, this is z to the power minus n, and this one is the Z transform of x of n. In the place of variable p, you can think it as a variable n. So this is the time shifting property which we have proved. So let us once again go through the proving. In the proving part, it was given to us that the Z transform of x of n is x of z. And we had to prove that if I shift this signal by a amount, say n, that means it will become x of n minus 1. Now, if I take the Z transform of x of n minus 1, we are going to get z to the power minus m x of z. So how will you prove this thing? So my signal is what? The signal has been shifted. The signal is now x of n minus m. Now you are taking out the Z transform of this signal, keeping in mind a reference that this Z transform of the original signal xn was x of z. Okay. If you see over here, this figure which I have drawn, so this you can take, this one was my x of n. This is my x of n minus m. Here m is 2. For this case, m is 2, right? So if this one's Z transform is xz, then this one's Z transform will be z to the power minus m x of z. So how we did the proving? We will take this variable inside this argument inside this, we will take it equal to p. Now put the places wherever it's n minus m as p and n is equals to m plus p. Now you'll find that this is becoming a summation in p, or the variable, the changing variable is p. So z to the power minus m, you can take it outside, and this portion will be of your x of z. So this is the time shifting property. In this case, the ROC remains the same as that of x of z. Okay, we will write it over here. The ROC is same as that of x of z, except for n equals to 0 if m is greater than 0. Okay. If m is greater than 0, ROC is same as that of x of z, except for n equals to 0. That means if, since the z to the power minus 1 is coming, that means it will become 1 by z to the power m x of z. Now this z to the power m, if you take this m as the shifting property of this one as n equals to 0, then this point, what is going to happen is, if m is greater than 0, then this is a positive number that is going to be here, and then you are not going to get this ROC will be same as that of x of z, except for n is equals to 0. Okay. Now let's do a question on this one also. Or let's do the time reversal property, and then we will be doing the question. Let's do the questions here itself. Okay, so the question is, we have to find the Z transform of x of n, where x of n is a to the power n minus 1 u of n minus 1. Now here you can find out by the simpler method, that is by taking out the Z transform of the complete signal, or you can use the time shifting property. So for this, you have to first identify the original signal. See over here, both of them, here also it is shifted by n minus 1, here also. So if it is not shifted, in that case, our original signal, what was my original signal? What should be my original signal in that case? A of n, a raised to the power n un. You know the Z transform of this one? N is equals to 0 to infinity. Now I'm not writing the full thing. A to the power n, Z to the power minus n. After doing sometimes, you will be able to remember it. N is equals to 0 to infinity. So the Z transform of this is basically 1 by 1 minus AZ inverse. Now, the question says that, the property says you that if Z transform of x of n is x of z, then Z transform of x of n minus m should be z to the power minus m x of z. Now let us identify all these things. So x of n is what for us? X of n is a to the power n un. What is x of z for us? X of z for us is 1 by 1 minus AZ inverse. Let us once check. Here it is 1 by 1 minus AZ inverse. Now, what is M? M for us is equal to 1. That means x of n minus 1. Now, this is becoming A of n minus 1, U of n minus 1. What will be the Z transform then? The Z transform will be becoming what? According to this one, Z to the power minus m x of z, Z to the power minus 1, x of z is this full thing. 1 by 1 minus AZ inverse. So this is your Z transform. X of z is equals to z to the power minus 1, 1 minus AZ inverse. Now this m, that is 1, this is greater than 0, so the ROC will be same. ROC will be what? Z inverse, AZ inverse, same as XZ. And what is the ROC of x of z? AZ inverse is less than 1. So A by Z is lesser than 1. That means mod A is lesser than Z. The Z will come down and it again goes that side. So mod Z is greater than E. That is your ROC. ROC will remain the same. This is the time shifting property. Okay, so we will be doing the other properties in the next class. Thank you, everyone. Meet you shortly.